much for having me. And I will say I'm really, really excited to be a part of ngVikings this year, just because if you look at the last two speakers right before me, we had Manfred Steyer and we had Aaron Frost, which are, in my mind, two of the amazing many, many leaders out there that are trying to push the limits of what you can do with Angular, push the limits of what you can do with web technologies. And they're doing it in a way that is really exciting and listening to the community and listening to the needs of what people are trying to build. So that's just so cool to be part of this community. And so today what I'm talking about is debugging the performance of 4,860 Angular applications. Now, that number is a little bit generic, but I'll explain what I mean by that in a little bit. So if you don't know me, my name is Fluin, and I lead developer relations on the Angular team. So my job on the team is really twofold. First, it's to help developers be successful with Angular. So helping them, giving talks like this, working with our GDEs, all those sorts of things to make sure that we're doing everything we can do to make you successful. But then also it's about listening for us, about being part of the community and making sure that we understand what it's like sitting on the other side of the screen, so that as you're building Angular applications, as you're learning and growing, we're reflecting those needs onto the team and making Angular better and better and better. So today's talk, I'm going to break it down into 3 parts. So I talked about this huge number of applications, and the number of applications goes up every day because every day I look at more Angular apps. But first, we're going to talk about some of the data I've collected. Second, we're going to talk through some of the worst practices I've seen across the ecosystem. And then we're going to make some recommendations and actually celebrate some of the good things that developers are out there doing. So let's get started here. So the data. I talk to a lot of Angular developers. This is a big part of my job, and so I have hundreds and hundreds and hundreds of meetings every year with different enterprises, with different businesses, different startups, all these sorts of things. And so I see a lot of Angular apps. And one of the most common things I'll say is, hey, can I see your app? Like, let's pull up the source code. Let's actually dive in and try and understand, what are you doing? What are the things you're struggling with? And so I want to try and act as a mirror and reflect some of the things that we're seeing back onto you, so that you can make sure that you're building the best Angular apps possible, which is the main goal of this talk. And there's really 2 ways that I collect data. One is in depth. So this is when we're going very, very deep into an application and actually looking at a single instantiation of something someone's trying to do. But I also try and balance that with a lot of breadth data. So understanding what's happening across the ecosystem, not just what's happening in one or a developer or someone that I'm meeting with, but what's happening across the entire ecosystem and across the entire industry. So depth really comes primarily from conversations and then pulling up code, right? This is one of the things that is kind of required for a job like mine, is you have to be able to get into the code, get in deep, understand what's going on, understand all these different contexts, all these different ways that people build applications, and go from there. So that's where the depth comes from. One of the things to know is that, and this is anecdata, this is not real data for this slide, but we find that about 90% of Angular apps are private. And what that means is they're behind a firewall. They're being built in some sort of context that is not shared with the world. And so there's no actual way for us to see them at scale, where there's no way for us to see the breadth of these applications. And so the only way to get data on these private applications is to have conversations. And so we know that most Angular applications are actually behind the firewall. They're building for employees, partners, all those sorts of people. And then only a small fraction are for public applications. So this is just based on conversations we've had. This is what we believe. And so these conversations often go, hey, show me your website. I'm going to pull up the network tab first, right? I'm going to be looking at what is the code that's loading? When is it loading it? How big is it? How long does it take? All those sorts of things. And then the second step that we always do is we pop over to a source map explorer. So this is a way that you can actually dive in and see not just what code you're shipping down to the browser, but where does that code come from? Why is that code being included in your bundle? And this is really the top principle to consider and understand. Excuse me. This is the top principle to consider and understand when you're debugging any sort of performance for any sort of Angular application. Because most of the time when we talk about performance in the context of Angular, what we're talking about is startup performance. Angular has very, very good runtime performance characteristics, where if you're changing a list of 1,000 items, it's going to work very well. It's going to go very fast. But the thing that most developers care about is how quickly can I get some content to the screen so that the user can start interacting with my page. When it comes to breadth, there's a couple ways that I try and collect this data. Obviously, we have a lot of tools as the Angular team. So we do a yearly survey to try and collect developer happiness, but that doesn't really give us a ton of insight into the apps that people are building. And so what I've done is I built a couple things. So I built a Chrome extension and a custom tool to try and help me understand what is the breadth of what's happening out there in the real world. The first thing that I built is a Chrome extension. If you search for Stephen Fluin in the Chrome Web Store, you're going to see this Angular inspector. Basically, what it does is it detects certain different frameworks like AngularJS, Angular, Apache servers. It just looks at the server headers. It looks at the HTML on the page. It can execute some JavaScript, just basically saying what is executing in order to make this page what it is. And one of the options, if you right click on the extension and say options, you can opt in to submit anonymous data. So it just says, hey, on this date, I saw this domain and it was running this version of Angular. So that's one of the sources of data that I get. And the other one is a bunch of custom tooling that I've built where basically I use Chrome headless under the hood and I load a page that's maybe loading Angular, maybe not loading Angular, and I scan it. So I do the same sort of things that I was doing in the Chrome extension where we look at the JavaScript that was loaded. So we can actually do string parsing and say, hey, did platform browser dynamic ever get referenced in the production JavaScript? I look at the rendered DOM tree, so I can look for things like ng version or Scully dash version. And then I can also evaluate runtime expressions. So I can check and see what things are people hanging on the window object, for example. And so I have run this tool on thousands and thousands of Angular applications at this point. And so I'm starting to build a higher level understanding of what's going on across the ecosystem, because there's a lot of really cool things you can do when you have this kind of custom tooling and say, hey, let's now start looking for forms module or reactive forms module and see how people are using these different libraries. So whenever I do this, I get out a little report. So when I ran it on Fluin.io, I can see it's using the compiler. It, at the time, was using version 900 RC4. I've got largest contentful paint. I've got the URL it actually ended up resolving to after redirects, etc. I'm using things like AngularFire. I'm compressing the content that I send down to the user. And this specific page at this time was also being server-side rendered, so it had universal. So we could see that this static HTML was coming down to the browser. So I will say, even though I've scanned thousands and thousands of applications, I don't have enough data. There are many, many more applications out there that I am not aware of, that the Angular team is not aware of. And so I will put this a little bit out to you, where if you want to share sites and be kind of counted from the perspective of understanding what sites are using what capabilities of Angular, what sites have these performance characteristics, we want to hear about it. So you can either always send me a site. I'd love to take a look at it. Or I built this really tiny, terrible app called bundlesize.dev, which is basically just a text box, and you enter the URL of your app and you hit scan site and you'll get back a bundle size report. And so we'll take a look at this and we'll see what that actually looks like. But if you enter a site here, basically I save that site and then I scan it every now and then for what version of Angular you're using and things like that. So across the scanning of the 4,000 plus Angular apps, I have seen some very, very terrible practices being performed by web developers. And so these are the types of things that make my son very, very sad when he sees it, because user experience really, really matters, right? When we think about Angular, it's apps that users love to use, apps that developers love to build in a community where everyone feels welcome. And if we're forgetting our users, Daniel just really gets upset. Sorry about that. So here is a terrifying number. So across the 4,000 plus apps that I have scanned, the average Angular app requires about 4 megabytes of JavaScript. So that is too much. That takes too long on mobile devices. That takes too long in disconnected scenarios, in places of the world where they don't have great internet coverage. That is much, much too big. But at the same time, acknowledging that that's what that is means that we can think about it and we can say, what do we need to do systemically to try and make this better? And just for your background, for your reference, the average non-Angular app that I've scanned is 5% bigger than that. So on average, Angular apps are bigger than non-Angular apps based on the sample size that I've scanned. So it's really a bad state of the world when our average JavaScript app is 4 megabytes for users. So that's something that we all need to do better. And that's part of why I give talks like this, is to try and drive good user experiences. There was one case where I was working with a team and they had a 15 megabyte bundle. Obviously, that's much bigger than 4 megabytes. And I will generally say that is too big. But it was a really great example of how easy it is to accidentally end up bloating your bundle size too far. And so what this team had done was they wanted to use SVGs, which seems like a really good idea, right? But they were putting SVGs in their CSS scoped to their components. And so what that ended up meaning was that SVGs were being encoded as CSS that had to be parsed, and that CSS had to be parsed as part of JavaScript, and that JavaScript all had to be executed in order to even have the SVGs in memory. even when they weren't being used. And so that was a really great example of like this chain of events that unintentionally led to this giant bundle. And we removed the SVGs and we got their bundle down by 13 megabytes. So it was actually a really easy fix in that case. But if we're not watching and we're not looking at these things, we're never going to find those things. The other really, really common thing that I see is moment locales. So I hate to pick on moment, but there are many, many examples where teams are unintentionally pulling in moment and then they're pulling in locales that they don't need. Or something that I've seen more often than I like is that people pull in the same locales multiple times through multiple imports across their application. So definitely be careful with your imports. And moment is just one example, right? You need to be careful anytime you're adding a dependency because you might be holding it wrong. One of the things that the Angular team is looking at right now is, for example, if you're using a CommonJS package dependency, we actually can't tree shake those very well, right? The Webpack configuration that we use isn't really able to leverage it. So we would rather people be using things like ES modules, because then we can actually do the appropriate bundling, do the appropriate tree shaking to give users the best performance without them having to think about it. But if a library is packaged in the wrong way, there's not a ton we can do about that. Another example that I see, and this really ends up happening a lot with large companies where they want to be doing all sorts of tracking. They want to be doing all sorts of understanding of the user, like understanding every click, every time they hover, every scroll event. And then they want to have some sort of live person pop up, and they want to have marketing and ads and all of that. And all of that ends up adding to the bundle size. And so most of these applications that I see out in the world that are 4 megabytes plus, it's not even the application's fault. It's all of the extra marketing things that they're doing. And so you always want to question, what is the benefit of the marketing that I'm doing? What's the benefit of the research and the analytics that I'm doing relative to the cost that I'm making to my users, right? The goal of these things are generally to try and make better user experiences. But if we're making our users suffer along the way, maybe that's not the right choice. One of the things that I see is that 13% of apps are still not using content compression. So we have 2 really good content compressions, right? We have gzip, we have Brotli, and they are almost universally supported across all the tooling, whether you're using .NET, whether you're using Firebase, any sort of CDN, Netlify, they're supported across Node. You just have to make sure they're turned on. And so 13% of apps out there are not using content compression. And this ends up being a really, really big deal because Angular apps generally compress pretty well. So I took a sample Angular app that was 352 kilobytes, it gzipped down to 101. I took my admin module, which had more of the editing features and authentication and things like that, of 379K, gzipped down to 97 and so on. And so if you look at these numbers, what you're going to realize is that your site is going to be 70% faster out of the box with compression, right? If you are network bound, you are just making your user pay triple the cost for the same site, which is not something you want to be doing to your users. Another of the recommendations we have based on what we see is that use CDNs. Right? They do a lot of this work for you. If you use some sort of modern hosting provider and you're not trying to roll everything yourself, you're going to get content compression out of the box. You're going to get HTTPS, where we still see about 3% of apps not using it, despite the kind of pushes across the board to make getting certificates, managing certificates easier, as well as pushing, for example, domain names and top-level domains that require HTTPS. Also, CDNs give you things like edge caching. So even if you have a large application, if it can be delivered to your user from closer to their geographic range, that's going to be faster. And there's newer, faster protocols like HTTP2 that can pipeline and stream down files a little bit faster with reduced overhead. So all of these things just come out of the box with modern hosting. So definitely take a look at using a CDN if you're not using one today. So I want to dive into the third part of this, where we're going to get into best practices and recommendations, and then we're actually going to do some live coding. We're going to take a look at some real applications. So these are the things that makes Daniel really happy, right? He loves small, fast user experiences. Recommendation number 1, stay up to date. So as you see here, this is like 4,900 applications. Most apps are on version 8, and version 9 is very, very close to surpassing that already, even though version 9 has only been out since February. So this is really, really good to see. Staying up to date will make your apps better. Every release, we make apps smaller without users having to do much. And that is a goal that we've held for ourselves for a long time. And it's something that we want to be doing more and more of every release, right? We are going to make Angular smaller and make your apps faster as long as you stay up to date. Right? And we make it really easy to do so with ngUpdate. And we'll take a look at that. ngUpdate is really designed to keep your application as up to date as possible, even when we have to make breaking changes to the platform. And so this is a thing that we have to do at Google. So anytime we want to push a breaking change to Angular at Google, we have to go and update the thousands of applications that rely on us. And so what we've done is we've taken that tooling and we've externalized it so that when you update a major version of Angular, your app is going to stay up to date. It's going to automatically get tweaked and fixed so that your app just keeps working. This is the only way we could scale our work at Google. And so we do the same thing for the world. And we want you to do the same thing for the world with schematics. So if you're not offering schematics and you're building a component library or some sort of tool, you should start thinking about offering schematics so that when you need to make a change, you don't make your users pay for it in terms of time and energy. You can actually take care of that for them and take on that responsibility. Lazy loading. We talk a lot about lazy loading. This is not a new topic, but it is one that always deserves a reminder because with lazy loading, we have really, really good support in our router. So if you use the router, you should be using load children all over the place. And because lazy loading means that you can only pay for what you use. And then you can intelligently decide, when do I want to go preload? When do I want to use heuristics to load those modules? Or do I just want to give them to the user on demand, where it's still going to be a much faster experience than if you had to go all the way back to the server for every page generation. So use lazy loading everywhere, basically. Measuring. So one of the things that we see is that every Angular application, the moment someone starts measuring it, starts getting smaller because they look at it and they say, hey, that's too big. I don't need that. And so we recommend this tool, Source Map Explorer. It's the kind of the best tool that's out there right now. There's a lot of other tools like Webpack Bundle Analyzer that we don't recommend because they can categorically miss some types or fail to classify some of our source maps. And so use Source Map Explorer. It's really easy to install. You globally add it or look at it locally to your project. Do a build with -- source map, and we'll take a look at this in a couple ways. And then run Source Map Explorer on your main or on any of your other bundles, and it will tell you exactly what you need to do. So we're going to do a real world demo. So we're going to take a application. So this was an application I didn't want to be too canned and pre-thought through. And so what I did is I have cloned, just close this for a second. I have cloned the Angular real world example. So this is a repo that's out there. It is a little bit out of date. We'll see if we run ng version, we're going to see that we're on version 7.3.1, which is a little bit too old. And I've already run an ng build -- prod and I've created this dist folder. And so you can see we've got polyfills, you've got runtime, you've got a main bundle, all these sorts of things that you'd expect to see. So what I want to do first is I want to ng update at Angular/CLI at Angular/core. Because as I said, if you update your Angular application to keep it as up to date as possible, it's going to make your application smaller without you having to do anything. And this is kind of magic when it works. And if you have a dependency out of date, you can try a -- force flag. -- force flag is basically ignore the mismatches. On here, Codealizer is still going to probably work with the latest version. And we can see is if we take a look at the source code, this is a full Angular application with lots of features. They're doing lazy loading. They're doing a lot of things right here. And one of the things we can do is as part of this update, as soon as it finishes installing, is it should actually be doing all of the migration. So it's going to make the changes to my application to make sure that the version that it exists on disk is going to work with the latest version of Angular. And this is kind of a magical thing. So you're going to see executing migrations. And so it's creating this file, for example, called browser list. And so this is one of the ways that we do in version 8. I think we introduced differential loading. So we shipped down a smaller ES 2015 bundle. And one of the things I'm going to do here just for our demo purposes is I'm going to say, let's not even generate the ES5 bundle. Let's say we're just going to target modern browsers with more than 5% market share. So that will be done. And as soon as this finishes up, what we're going to do is we're going to run another production build, and we'll actually compare the file size. And that worked. So I'm going to make one last change here. So in our Angular JSON, in the production configuration, I'm going to say source map true, because we always want source maps, and name chunks true, because I don't think that's really a security concern. What it does is it gives us names for all these chunks so we can actually compare them and look at them over time. So let's do this ng build -prod again. So this will take a little while because it's going to need to do all of the compatibility compilation for Ivy. But as soon as that's done, we'll take a look and compare and contrast the bundle size. And we'll take a look at some of the reasons that this bundle size might be bigger than we might hope for. All right, so let's leave that in the background while it's compiling. The next thing I want to talk about is server-side rendering, because last year, basically no one was doing server-side rendering in the Angular ecosystem. So among the sites that we were scanning, it was something like 2 or 3% of sites were doing any sort of server-side rendering. Based on the sites that we're scanning right now, it's more than 25%. So server-side rendering has taken a huge step up in the world in terms of delivering high-quality, machine-crawlable applications. So there's really 2 reasons you should consider server-side rendering. Number one, as I mentioned, machine crawlability, right? If you are targeting a search engine that doesn't support JavaScript, this is really, really important. If you're targeting shareability, you want to be able to share your links on Facebook or Twitter or whatever social platform, they don't have JavaScript capabilities, right? They need to load the page as straight HTML, do some simple parsing, and then fetch out the image based on those tags that you're giving. So if you want social sharing, you should probably think about server-side rendering your application. And then there's also a perceived and performance benefit. And I know Aaron talked a lot about this in his last talk, but by sending down the HTML pre-rendered, the client side doesn't have to bootstrap for the user to feel like the page is done, even if it's not, even if you're doing a client-side bootstrap, which you can optionally do. Another technology you should be thinking about is budgets. So every time you build a new Angular application, we're going to be putting budgets in for you by default. So we warn at 2 megabytes and we error at 5 megabytes. But you should probably tone these back, right? As we saw, Angular apps are too big. So maybe consider a 1 megabyte warning and a 2 megabyte error. So we can get away from having these 4 megabyte applications for an initial bundle. We also can warn, by default, we warn on the component style size. You can tweak that to your heart's delight. We generally want to warn people and push people into having very, very small component styles. All right, I think our build should be finished here. So what we can see is if we look at our dist folders and we compare our old main file. Actually, let's zoom out just a tiny bit so this is easier to do. Oh, I made a boo-boo and I didn't save the old dist folder. So we're just gonna have to compare. So we had an old main file of 385 KB. And now just by staying up to date, as you notice, we didn't need to make any code changes. We're now down to 341. And you can see that all the lazy loaded bundles shrunk as well. So the last thing I want to do is I want to npx, I'll just use the global version to save us an npm install. I'm going to use Source Map Explorer on dist/main ES2015. And what this is going to do is it's going to allow us to take a look at the bundle. And we're going to see, okay, so there's a bunch of stuff coming in from Angular because we're using a lot of the features like router, the core, we're using platform browser, we're using HTTP, we're using RxJS. And then if you click down here on app, you're actually going to see all of the parts of your application, see how the code that you're writing is actually contributing to the bundle size. But one thing that's a little bit weird about the real world Angular app is it doesn't really use forms on the homepage. And so if I was debugging this application, I would want to go in and figure out, okay, why are we pulling in forms? And if you take a look at the source code, what you'll find is that in the app module, they're pulling in this shared module, which pulls in the forms module. So this is an example of where you've now made forms required for your user to load your homepage, even though it's conferring no benefit to that user. And so if I was working with this, the authors of this app, what I would say is, hey, maybe you should actually have your login and registration features, which actually require this forms module, in another lazy loaded route, right? They do a lot of lazy loading here, but there's always opportunity for more, right? Because they've got a settings profile editor article. So all these are great lazy loaded modules. But for example, authentication is not a lazy loaded module. So consider making that a lazy loaded module as well. So you can really just pull in less. There's always opportunities to be pulling less because unless your code coverage is at 100%, where the browser needs 100% of the code to execute in order to render your screen, there's probably something you could leave out, something that you could lazy load. All right, back to our slides here. All right. There is also an initiative coming from the Chrome team called Web Vitals. And so this is trying to push simpler metrics in order to communicate the size and quality of a web application based on performance. So Web Vitals is based on 3 things: largest contentful paint. So that is, what is the biggest paint that we do and when does it happen? Cumulative layout shift. So every time the layout shifts, how much does it change? So that we minimize that. And then first input delay, which actually requires a human to click, and then we measure how long that click has to wait in order to actually execute. So I'm going to do one final demo here to kind of show off some of the ways that you should be debugging your Angular applications and looking at performance. And so we are going to do some lazy loading and app setup. We're going to use Source Map Explorer, and we're going to reconfigure Angular JSON as we saw before. And then we're going to take a look at source maps, and we're going to check the network tab. So these are all things that you should be doing in basically every Angular application that you do. All right, and I think I'm a little bit over time. Please yell at me in the speaker chat if I need to shut up. But what we're going to do is we're going to take a look at this Scully test application. So if we ng-serve this, it should be just a regular Angular application with just the kind of hello world code. So if we look at the source app, we're going to see a standard app component. And what we can do is we can delete this. Now, I've run 2 commands even before getting here. I ran a generation code, which is really, really simple. It's you basically just say ng generate module -- module app.module -route. We'll call it Viking. And we'll call it our Vikings module. What this does, oops. Or dash dashes, sorry. Helps if you type things correctly. All right, so what we've done is this is a really cool command that I recommend everyone try. It generates a module and registers a component in it, in that module, and links it from our routing config. So if we take a look at the source code, we can actually see in our app module here, our app routing module, and we'll reformat this. It has created a Viking module, right? It just got added to our application. And we can do the same thing. I think my sort of, yeah. So we've added a Viking module, and that worked great. And now what we can do is we can do an ng build. And before we do that, I want to modify my Angular JSON, as we talked about. So we're going to source map true. We're going to name chunks true. That should give us a source map explorable version of this application. And I think I'm out of time actually, so I'm going to skip one part of the demo, but this works exactly like it would with the real world application, where you generate source maps, and then anytime you want, you can go in and run Source Map Explorer and analyze each of the bundles. And then what I meant about the network tab is that when you take a look at the application, you should always just have the network tab open and see what it's actually loading when it's loading it. So if I say Viking, it should say Viking works. And we can see that we don't load the Viking module until we actually hit that Viking route, which is exactly what we want to see. And that means that we're doing lazy loading in the best way possible. All right. So to just sum us up, looking at metrics is really, really useful, and that's how you're going to get the most performant Angular applications. But I will also say, looking at metrics can also miss the point sometimes, because you have to consider what value you're trying to deliver for your users. If you're trying to build a dashboard that users are going to be staring at for 8 hours a day, and they're only going to load it one time that day, performance is probably not your top concern, right? You're going to care more about user experience, or you should be thinking more about animations, internationalization, all those sorts of things. And so always try and reflect about the performance and the size of your application in the context of your app. And try and have fun, because even if you have a large application, unfortunately, you're in good company. There's lots of really great applications out there that are too big and should be doing these sorts of things. But really, really focus on what is going to be delivering the best experience for you users. Thank you so much for having me. I've been Stephen Fluin, and I think we're heading over to a speaker panel now.